Now we're going to look at three-dimensional figures, which can be sometimes hard to visualize when it's printed just on a paper, and sometimes they can kind of flip on us. So just do your best with these, and really what we'll want to do is grab the numbers from it and start plugging into formulas. So with three-dimensional objects, what we're going to be interested in is volume. So volume represents the space that a three-dimensional object occupies. Now, in terms of this, so perimeter, we talked about how it was a length. So with our units, it is just the same as adding up lengths like on a ruler. With area, we talked about having a grid, and with that, it's kind of how many squares would fit inside of that region. And with that, area would end up with units squared. Now with volume, what we'll be thinking about is cubes. We're going to see, and you can kind of see in the picture down here, of how we think about each of these little cubes. I can kind of zoom in here. It's like here's one cube that fills up some space within that object. So with that, we want to know how many of those cubes would fit inside. So with these, what we're going to end up with is whenever we get our units, we're going to have units cubed. So you'll see exponents of 3 coming up, or you could say cubed units, whatever we are working with. So what we're going to look at on this page is just a general idea of calculations of volume, and it will apply to a few formulas that we look at on the next page, but it's this volume of prisms. So there are different types of prisms that we can have, and it's the idea that the prism will be made up of a shape that we've already looked at previously with area and perimeter, so it'd be something we're familiar with, but then we're turning it into a 3D image. So what happens when we deal with this shape we already know and then turn it into something 3D is that typically that shape that we have worked with before in terms of area is that'll represent the base. It's kind of the base area that we're looking at. And then when we make it into a three-dimensional object, it's kind of like it starts repeating, and I'll show you with these prisms that we look at on this page how this comes through. But with that, what we can do to get volume is once you have that area of the base, then you want to think about the height of the prism, and multiplying those together will give you this volume of a prism. So let's look at this first example here. And this is just 3 stages of thinking about volume with this image here. This right here would be a rectangular prism. Now in terms of base here, you could see at the bottom of this, like along there, we have a rectangle. So this would be our base. And then it's the idea, and you could almost think of like, what if this was a cake that we have, a very tall cake that we have here. The idea is if you start slicing into this image, no matter where you'd cut, you'd get the same rectangle out. You'd have a 7x5 rectangle no matter what stage of that prism you cut into. So that's what makes it a prism and a rectangular prism, because that rectangle would be showing up each time. So in terms of this, let's think about our base area. So base area is this 7x5 rectangle. So what we would do is use our formula for a rectangle, length times width, or width times length. So we have 7 times 5, which is 35. And let's actually talk about units for a little bit. I'm gonna break this down even further just so that we get our units correct when we do these calculations. Because really what I have is 7 inches times 5 inches. So numerically, 7 times 5, 35. Now units, and this happens when we work with variables as well, like if I had you take x times x, that would be x squared. That's what's happening with our units here as well, and also this is area, so we just always squared our units anyway, but this is where it's coming from, is that we're multiplying inches times inches, which would be inches squared. So that's where our little exponent's coming in. So that gives us the area that's being occupied by this base here. Now this next image shows how we could start turning it into volume at a very small scale. So we'd have here is we know we have these 35 square inches here, and then what they did is kind of like they raised them up by, here's 1 inch. So with that, it's turned into cubes. But what we would have is 35 individual cubes here. So what we can visualize here is how we have these 35 cube inches. So it changed proportion, it changed units because now it's three-dimensional. It's no longer just squares. Like at this stage, what it could have looked like if I was more careful with my drawing is separating by 7 and separating by 5, and it's too hard to do there, but then we would have 35 squares, and now we have 35 cubes using the units of inches. Then what we want to do to get to the idea of volume, which is our next step here, is where we know down here we have these 35 cube inches. We want to repeat that. And how many times it's going to repeat is going to match this other number that was given to us, which is the height of the prism. So we have is this base coming through here in blue at the bottom, and then we have this height that tells us how many times it's going to repeat. So we're going to have 35 and 35 and 35 and 35. And it's like instead of just adding 35 over and over again, that's where we get multiplication. So that formula up above there, that base area that came from the 7 inches times 5 inches. But then what we will need to do to make it volume is then think about the height so that we know how many times is that base area repeating. So that's where we go times height. So what we're going to do is then multiply by 11 inches. So numerically, 7 times 5 times 11, which should give us 385. And then in terms of units, we have inches times inches, which is inches squared, but then we're multiplying by inches again. So that's where we get inches cubed. So that's how we can think about volume for a prism. We want to think about this base shape, take the area of that, and then we'll multiply by the height of the prism. So let's try that out with this scenario. So this right here with the base, and this is where we can kind of, that example that I was saying with cutting the cake, you want to make sure that when you cut the cake, that is the prism, that you get the same image over and over again. So like if I cut the wrong way here, like if I started cutting along this way, it's kind of hard to do with three-dimensional, but it's that I get a different shape each time. Like I'd have a really almost rectangular piece at the end there, and then here I'd have something triangular, totally different each time. So with that, if I try it that way, I would know I'm not visualizing it correctly. But if I started cutting this way, like this, then I see the same triangle, and the same triangle, and the same triangle. And that's where I can start to see what my base is for the prism. It's that repeating image throughout the picture. So the base here is going to be this triangle. And what would make this even better, and we'll just assume that it's there, we'll assume this is a nice right triangle there. So with that, for base area, we can think about this 7.5 by 8 right triangle. So with that, it's triangle, so 1/2 times base times height. So 1/2 times base of 7.5 times height of 8. So with that, we're getting this base area of 30 inches, and that would be squared. And just to kind of go through like I did up above there, that 1/2 piece doesn't have any units. In fact, I'll write it as the fraction, that's just part of the formula. But the base of 7.5, that has units of inches, and the 8 has units of inches. So that's where numerically we do take 1/2 times 7.5 times 8, which gives us the 30. And then in terms of units, there's no units there, but inches times inches will give us the inches squared. And then when we see this next picture, it's the idea of turning it into something three-dimensional. So we know we have have these 30 squares there, and then if we give them a little bit of height, a height of 1 inch, then they become 30 cube inches. So we have these 30 cubes here, even though some of them are cut up. It's the idea like putting those together would make 1, 2, 3, 4, and the rest will kind of make up the rest. So to make it volume, we know how many cubes we have at the base there, and then we just need to repeat it to run the whole height of the prism. So for volume, we're going to take that base area, which was the 1/2, and I'll actually write all of this out. The 1/2 times base of the triangle times height of the triangle, and then we need to do times height of the prism, which is 16 inches. So numerically, plug in the numbers, multiply them up, and that should be 480. Then in terms of units, no units on the half, but inches times inches times inches. So we'll have inches cubed. So that's a way of thinking about volume of prisms. Now let's look at some formulas and examples here. So with the cube, cube would have all the same side lengths, and this would be a case where the base would be a square. So it's kind of like we're taking our base times height. So base would be a times a, and then times height, which is also a. So that's where we just get a formula of a cubed. So let's say, for example, I have this cube with a side of 2 inches. So for volume, we'd have 2 times 2 times 2, or you could think of that as 2 cubed, which would give us a volume of 8. And then our units are inches, and volume always has cubed inches. So that would be a cube. Rectangular prism, which we did on the other page there, that idea that the base would be this width times length, and then we need to multiply by height. So we have this base times height here. So let's say we had a rectangle here. I'm going to say this is 2 feet, and let's make this 8 feet and a height of 3 feet. So for volume, we'll just take 2 times 8 and then multiply that with the height, and that should be 48. And then we're using units of feet, so we'll cube it. All right, our next one here is a pyramid. This is not a prism. If we cut into this one like a cake, we're going to get a different shape each time. A property that is here that you can look up on your own, like if you look at this formula here, we just saw this length times width times height, as we did up above here. A pyramid is just 1/3 of a rectangular prism. So it's like you could line up the length times width, and then it'll just take up 1/3 of that space there. There are all sorts of visuals on YouTube for that if you want to look into it. But let's look at an example here. So we'll have length times width for the base of our pyramid, and then we'll have to think about this perpendicular that drops from the vertex to the middle of the base. So it is making a 90-degree angle there. So that's a piece that we'll need to understand. So let's say we have this pyramid here. Let's make this 2 meters, 3 meters. So that's our base there. And then I'm going to drop this perpendicular down to the middle there to make a 90-degree. And I'll go ahead and say that's 5 meters. So for volume, we would take 2 times 3 times 5, and then since it's a pyramid, divide that by 3, which should be 10, and then our units are meters, and we'll cube those units. All right. A cylinder, which is really like a circular prism. This is a form of prism where the base is a circle. So if we cut into this, we'd see a circle each time with the same radius. So what we want to do is think about the circle as a base and then the height of h. So you can see that in our formula, like area of the circle is pi r squared, and then times the height, which is h. So for example, if we had a cylinder here, and let's go ahead and make the radius 3 inches, and let's say the height is 6 inches. Then for volume, what we would do is take the pi r squared, so find the area of that circle at the base. So pi times 3 squared, and then multiply that with the height, which is 6. Plug that into a calculator, round to 2 decimal places, should be 169.65, and then units are inches, and then we'll cube those units. All right, just how the rectangular prism linked to the pyramid in terms of 1/3, same thing happens with a cone. So cone has a circular base, so it would fit in with the cylinder, and it would take up 1/3 of that volume there with that same radius and height. So you can see in the numerator here, same formula as up above for cylinder, it's just we're taking 1/3 of it. So with this, what we'll do is to give you some numbers to work with. Let's say it has a height of 5 centimeters. And then let's go ahead and say the radius is 2 centimeters. So for volume, pi r squared, so pi times our radius of 2 squared times the height of 5, and then we just need to divide by 3 to make it a cone. So volume of 20.94, and then centimeters cubed. And then our last one here is a sphere. So with a sphere, all you need is a radius for measurement, and the rest can be done with this formula right here. So you're going to have 4/3 times pi times whatever the radius is cubed. So let's look at an example here, and let's make that radius 3. Let's say that radius is 3 meters. So for our formula, we'll be taking 4/3 times pi times 3 cubed, and we'll just plug all of that into the calculator for 113.10 meters cubed. So there are some different formulas that when you have prisms, you can kind of adapt it to the shape that you're seeing in that prism. You just do that base times height. But then like the cone, pyramid, and sphere have their own formulas that you'll need to use.